Welcome back, dear friends. So in this video, we will see some of the analog sensors, how to interface with Arduino. Okay, so let us start the topic with first LDR, then LM35. So LDR is the sensor which is used to measure the light. LDR means light dependent resistor. Based upon the light intensity, the resistance of the LDR will change. With respect to this change, we can calibrate and we can use this value for measuring the light intensity. And LM35 is a sensor used for measuring the temperature in degrees Celsius, and also we can convert into Fahrenheit. Okay, so let us start the topic. So for doing this interfacing, I used a software called Proteus, which is very simple and user friendly, available in the Google, and also you can purchase the license. Okay, let us see the circuit diagram which is used for interfacing the LDR with the Arduino, and also I have used the LCD for displaying the values of the LDR here. Okay, so let us see in the Proteus software itself. Since you are the, you might be knowing, or some people may not be knowing this software. So this is a ISIS professional. Okay, so just go to the library. So pick device or symbol. You will get a library of components. So whichever the component you want, select them, and it will show the variety of components in that particular type. So for Arduino, I have this many types of Arduino. So I choose Arduino Uno and give OK, and place where you want to keep it. Since I have already here, I am not keeping it. I'm just giving escape so that it goes back. So similarly, you can choose all these components: LDR, resistors, and LCD. Just type here, you will get the components LDR. So LDR active, like this. Okay. Similarly, for LCD library, just type LCD. You get the types of LCD here. So 16x2 is the LCD which I've connected. You can choose over this. Just give OK, and you can see here it is available here. Okay. So since I have taken it already and I have connected it, so I'm just giving escape. And about the code, you have to use Arduino IDE, like which I told you in our previous video, which I explained how to interface the digital sensors. I have shown you how to use them. I think this is not the one. Okay, so let me take the file which I have used it. I have stored it, actually I have saved it. Let me open that one. It is in the folder. Okay, so I have not saved that code. It's okay, no issues with that. So once you write the code in the Arduino IDE, okay, so you have to write the code in the Arduino IDE. I will show the code here in the PPT. Okay, so you have to write the code in the Arduino IDE, and then you have to compile the file So once you compile, you will get a X code, and that X code you have to copy it to the desktop. So just by clicking, double click, it will ask you where you can find the X file. So if you press that one, it will show. You see, I have copied this X file here, so you can just place it over here. So now the code is available here. So code, we have to write it in the Arduino IDE and generate the X file by compiling it. Okay, you have to compile. This is a compilation. Just do the compilation. So in the temporary file, it will store as a X file. So that X file you have to copy it and keep it in some easy accessible place, and then double click over this Arduino board, choose that file where you placed it, and then it is ready for simulation. So let me simulate this. Okay, so now I started simulating this. Now the LDR is having the light, and I slowly decrease the light intensity, and what happens, the value of the resistance also increases with respect to the light decreases, the resistance of the LDR increases. So the voltage drop across the LDR also increases. That is being shown here, and as a voltage itself, you can see here how it is increasing. So when the light is decreasing, then you can see respectively the voltage also get increases across this LDR, and vice versa case. If I increase the light intensity, the voltage getting decreased. So that value is red, and then it is being displayed. So this is a raw value. So you can calibrate this raw value into the percentage or any other thing, and then you can do the code for switching off the street lights, the switching off the light in your home, whatever the requirement is there, you can do that variations. Okay, so just using this value, you can compare if this particular value is there, switch on the light, or this particular value is reached, switch off the light, electrical light. Okay, so based on the sunlight which is available outside, we can control the light in our home, or the gardening light, or street lights. Okay, so that is a simple application of it, this LDRs. Okay, so now let me show you the code. So I have a code here for this. Okay, so I need to display the values in the LCD, so I need to include the LCD here. Include liquid crystal.h. This is a header file for LCD, and I need to define the pins which I am going to use it for connecting it with the Arduino and the LCD. So I have chip select pin, enable pin, on 4 data pins here, and these pins are going to be connected 12, 11, 5, 4, 3, 2 pins of Arduino respectively. Liquid crystal, LCD, this is the sequence we have to write. So if you are well versed, so we need not to write this second line directly. We can write here 12, 11, 5, 4, then 3, 2. So these numbers can be of any numbers. So it is not necessary that always you have to use 12, 11, 5, 4, 3, 2. You can use any number which you would like to write. So it should be inside the Arduino board. Okay, so like a 13, 12, 11, then 10, okay, 9, like that we can use, no issues with that. And I declare a variable called a sensor value. Okay, so this variable is for storing the analog values here. It's like a memory location. And I define in the A0 pin, the sensor is going to be connected. Okay, so we need to declare to the Arduino which pin we are connecting the sensor. Okay, so then only it will go and fetch the data from that particular pin. And this is setup loop where we are just beginning the LCD. Okay, so LCD.begin 16, 2. So what is the meaning of this 16, 2? 16 is the number of characters, and how many lines is there? 2 lines is there. So we have 2 lines, and each line carries 16 characters. So totally we can print up to 32 characters in this LCD. And there are different types of different size of LCDs. 20 into 2 is available, 20 into 4 is available in market. Suppose if you are using 20 into 4, you have to write here 20 comma 4. Okay, and that is about the setup. And in the loop, we are writing a simple code here, wide loop. We are just collecting the data of analog sensor. You see, sensor value equals to analog read A0, means you read the data from the A0 pin and store it in the memory location sensor value. This name can be of anything like X, Y, Z, anything. You can keep it here as per your requirement. You can write LDR value, or you can write any comfortable name. You can give it here. And I need to print it in the LCD, so I'm just clearing the LCD. Any garbages values should be cleared off. And LCD dot set cursor 0 comma 1, so that means the second line, 0th position it will set. And what it will print there, it will print a sensor value equals to, these characters will be displayed there. And in the next 12th position and first line, it will print also the sensor value. This is the value which we are getting in the sensor. Okay, so this is what we are seeing in the simulation there. Okay, so in the first line, so this is the 0th line and this is the first line. So first line, 0th position it starts, and the 12th position it is starting printing the values. Okay, so this is how we interface light sensor with Arduino. Okay, and let us go to the next one, so which is nothing but temperature measurement. Okay, so this is almost similar to the previous one. I just replaced the LDR with temperature measuring sensor. So this is a LM35. We have different type of sensors, so I have just taken LM35. Okay, so this can measure the temperature in Celsius, and then we can convert that into Fahrenheit as well. So here we can see in the LCD, I just displayed both the temperature in Celsius as well as in the Fahrenheit. Okay, so let us see how the coding is being done and how the simulation is done. So before seeing the code, let us see the simulation for that. And let me open that. Let me open that one. I've stored it here. Okay, so this is the one. So let us see the simulation. I have already chosen the program and everything here, the same procedure. Okay, so here it shows the temperature in Celsius as well as in Fahrenheit. I can vary the temperature here so that the respective values also displayed there. So here it is 20 degrees in the temperature sensor, and 20 degrees Celsius is displayed here, and it is being converted into Fahrenheit 68. 19, 18, 17. Okay, so this is how it is being simulated here. This LM35 also available in the library. Just type LM35, you will get this one. Right, now we will let us see the code for this. So this line, first line is same, and second line also is going to be same, and almost this off is same like the previous code. Okay, liquid crystal, we have included header file, declared the pins, and declared it in the format, and then we declared a memory location, and I declared where I am going to connect the sensor, and I just begin the LCD here. Okay, in the loop we are going to modify the program. In the wide loop, we are reading the data, again the same pattern. We are reading the data from the temperature sensor, and it is being stored here as a raw value. So this raw value we need to convert into millivolt range. Okay, millivolt range, and that will be converted in this scaling operation, sensor value divided by 1024 into 5000. So this is a, we are converting into millivolt. So the value which we are getting is ranging from 0 to 5 volt. So the volt is need to be converted into millivolt. So we are converting it, multiplying it with a 5000, and these values are ranging from 0 to 1024. So that's why we are dividing them with the sensor values divided with this 1024, and we get the millivolt. Per millivolt, per 10 degrees, 10 millivolts, we get 1 Celsius. So that's why we divide this millivolt value with the 10. Okay, so that means, so 10 millivolt is equals to 1 Celsius, like that. Sorry, 10 degrees Celsius equals to 1 millivolt. Okay, so that Fahrenheit needs to be converted. It's a simple formula here. So Celsius into 9 divided by 5 plus 32. So this is the standard formula, and we are going to display them here in the LCD. So 0th place, 0th line and 0th position, temperature in Celsius will be printed, and 12th position, 0th line, you will get the value of the Celsius, that is temperature in Celsius, and 0th position, first line, we will get the temperature in Fahrenheit, and then second, that is first line, 12th position, you will get a Fahrenheit value there. So that is what you see here in the display. Okay, so by varying this temperature in the sensor, you can see the also the variation here in the LCD. Okay, okay, hope it is clear. If any doubts is there, you can let me know in the chat box. Okay, and in the next video we are going to discuss a few more analog sensors, and like we will discuss DHT11, and we will discuss also other analog sensors like pressure sensor, okay, and ultrasonic sensor, IR sensor, PIR sensor. So there are many more sensors out there. Whatever is possible, we can cover in the next video. And once we are familiarized with this digital and analog sensors, then we will go for the little more complex programs like interfacing GSM modules and interfacing Wi-Fi modules. Okay, so we will go one by one and we will learn. So once we learn all these modules, how to interface them, then we can put them into the application, and we can see also few application programs. Okay, hope it is clear and will be helpful for you. Thank you for listening. Your support is highly appreciated. Thank you so much.